Part C. The number of times the dice have to be rolled to halve the number of dice in the tray represents the half-life. Okay, we know that. The image below shows an 8-sided dice and a 6-sided dice. There's the 8-sided dice there. Here's the 6. The student now used 8-sided dice to model radioactive decay. Dice that landed on number 6 were again removed from the tray. The half-life represented by rolling 8-sided dice is likely to be different from the half-life represented by rolling 6-sided dice. Explain. Okay, remember that's going to be a describe plus, isn't it? How? That's worth 2 marks. 1, 2. So what are we likely to find? Well, the first thing, let's compare the dice. We're going for a 6 on this one and a 6 on this one. Well, there are only 5 other alternatives here. If you haven't got a 6, you could either have a 6 or you could have a 1, 2, 3, 4, 5. Whereas here you could have 1, 2, 3, 4, 5, 6, 7 or 8. So there's less chance of rolling a 6 with this dice than with this dice. So that's the first thing we can notice about the dice. There is less chance to roll a 6 Okay, we actually know the chance is 1 in 8. Compared to the 6-sided dice, where it's 1 in 6. Okay, so what does that mean? Well, that means it's going to take longer for us to get half the dice to have a 6 here, surely. It's going to take, because it's not just going to, here we knew it took 5 rolls to get half the dice to have a 6. Well, here it's less chance of getting a 6, so it's going to take longer. So we've described the difference between the 2 dice, explained how that's going to impact, well, the half-life of the 8-sided dice. 8-sided dice will be longer. Okay. A teacher has 2 radioactive sources, A and B. Source A has a longer half-life than source B. What can be deducted about the nuclei in source A compared to the nuclei in source B? Do not refer to isotopes in your answer. Okay, so do not mention isotopes. What can be deduced? Okay, so what can we tell about the nuclei in source A compared with the nuclei in source B? And source A has a longer half-life. Okay, so something's got a long half-life, it tends to just be more stable. It doesn't stability we often think about kind of things falling over and collapsing. So in terms of buildings, we talk about stability of buildings, or I'm thinking about sort of stability of a rugby scrum or something like that. It's how likely it is to fall over and collapse and decay into something else. So this one here, source A, is less likely to decay. It decays slower, which means it's going to be more stable. So A decays slower. Than B. So it, don't like it, I'd rather not use it, so source A is more stable. Okay, I've thought about that word there, the compared word in the it's not necessarily a command word, but I am comparing the two. So source A decays slower, there's a comparison word, than B, so source A is more stable than source B. Okay, because it takes longer to halve. Okay, hope that's helpful.